So the dotted line that we've sketched here is the path of the tip of the r of t vector. At least it's a depiction of that path. This also gives us a curve in x and y, so that we see that along this curve, for every x there's exactly one y, so that y is indeed a function of x. Let's see what that function y of x would be now. If x of t equals the square root of t, then just using x and suppressing the t, we have x squared equals t. So the t is equal to x squared. Now, since y of t is 1 over t, and since t equals x squared, then y of t is 1 over x squared. We have a function y equals 1 over x squared. Now we've lost our t information in doing this, so we don't know exactly where we are along this path at any given time, but we know this path coincides with the graph of the y equals 1 over x squared function, as long as t is greater than or equal to 1, making x greater than or equal to 1. So that the path lies on the graph of y equals 1 over x squared for x greater than or equal to 1. Let's consider another function, r of t cosine t I plus 2 sine t j plus 1/2 t k. Now we're going to start by just considering the function in the xy plane. We'll worry about the addition of k in a minute. So in the xy plane, cosine of t I plus 2 sine of t j. If t equals 0, this is going to give us the point 1, 0. That would be here. If t equals, let's say, pi over 2, making the cosine 0, we find that the sine of pi over 2 is 1, giving us the point 1, 2. So we have the point 1, 0, and I think I said this wrong, 1, 2. This is 0, 2. Now how do we get from 1, 0 to 0, 2? It turns out that we follow a smooth curve that is a part of the ellipse that would be constructed within this box. And the path continues around the ellipse. If t equals pi, then we have -1. The cosine of pi is -1, -1i plus 0j. So we're going from our t equals 0 point to our t equals 1 point to our t equals 2 point. I'm sorry, t equals 0 to t equals pi over 2. To our t equals pi point, and our t equals 3 pi over 2 point. And this would be the function, let's call it r1 of t equals cosine t I plus sine t j. We can prove that this is, in fact, an ellipse, and I left off the 2, that's 2 sine tj, by the fact that sine of t is the square root of 1 minus cosine squared of t, so that this function is can be written as cosine of ti plus the square root of, and I left off the 2 again, we'll say that's plus 2 times the square root of 1 minus cosine squared of t times j. Cosine of t is just x, so that's xi plus 2 times the square root of 1 minus x squared j, meaning y is 2 times the square root of 1 minus x squared. If I square both sides of this, I get y squared equals 4 times 1 minus x squared, which can be rearranged into the form 4x squared plus y squared equals 4. Divide both sides by 4, we get x squared plus y squared over 2 squared equals 1, and this is the equation of the ellipse we just sketched.